Welcome to online learning program of MSBT Lead Learning at Your Doorstep. I am Professor Deepak Kulkarni, Head of Electronics and Telecommunication Department from KVM Polytechnic Mumbai. Welcome you all to the presentation of Digital Factory, in which we will focus on Internet of Things. After completion of presentation, the learners would be able to understand the various data routes from sensors to cloud. After this presentation, the learners can try to answer the questions like state the need of gateway and what functions are performed at the cloud or server level. In this presentation, we will see the need for different data routes and what are the different routes available between the sensors to cloud. As we can see in the concept map, at the level 1, various devices or sensors are employed, which will gather the information and is then given to the gateway, from which it will be forwarded to the cloud, and after processing and information extraction done and analysis done, it is then given to the end user or to the system. So this is the basic model of our IoT subsystem. So in this subsystem, we will now focus on the different routes that are available between the sensors and the cloud. Now let us see what is the need of the various data routes. The different data routes will enable communication between different technologies, and it will serve as an entry and exit point for all the network data. At this level, students can attempt MCQ set 1 given informative assessment. Now let us see the various data routes available. The first data route available is sensor to PLC to SCADA and then to the cloud. This is a conventional data route, that is, it is one of the most traditional and widely used data route. In this, as we can see in the diagram, the field device, that is a sensor, is wired or networked to a local programmable logic controller. Since this is often the nearest programmable system to the edge component, the PLC requires device-specific communication driver or instructions to obtain the data that may involve choosing the desired points and mapping them in a spreadsheet format. Next, the PLC data is networked to a PC-based HMI, that is a human machine interface, or a SCADA system, which approach requiring of data tags, configuration and drivers. The HMI or SCADA needs additional configurations or programming steps to transport the data into the cloud-based database, where it can be made more widely available. The information from the SCADA or HMI will be given to the cloud through the gateway. So this is the most widely used or a conventional data route. The next data route available is through the use of gateway between the sensor and cloud. This system will have 3-level architecture. In level 1, we have got devices. In level 2, we have got gateways, and third level is a data system. The data moves between these levels in 4 types of transmission channel. The first one is between device to device. Direct contact between the 2 smart objects is done in this, where they share information instantaneously without intermediaries. For example, industrial robots and sensors are connected to one another directly to coordinate their actions and perform the assembly of components more efficiently. This type of connection is not very common because many devices are not able to handle such processes directly. So the second link that is available is between device and gateway. It is a telecommunication link between the sensor and gateway nodes. Gateways are more powerful computing devices than sensors. They have 2 main functions. The first is to consolidate data from sensors and route it to the relevant data system to analyze data. And if some problems are encountered, then it will return it back to the device. There are various IoT gateway protocols that may suit this depending upon the gateway computing capabilities, network capacity and reliability, and the function of data generation and its frequency and its quality. So an appropriate gateway protocol must be selected based upon the requirement, because it acts as an intermediate between the sensors and data systems. The third link available is between the data systems and gateway. To determine which protocol is to use at this level, we should analyze data traffic, in which we should determine the frequency of burstiness and congestion, security requirements, and how many parallel connections are required. Based upon this, we will find a suitable protocol that operates between the gateways and data systems. And the fourth one is between the data system. That is the information between the data centers or cloud can have between in these nodes. Protocols for this type of connection should be easy to deploy and integrate with existing applications which have higher availability, capacity, and reliable disaster recovery. So in this route, a gateway acts as an intermediate between the sensors and the data systems. The next data route also involves a gateway, but in this case we have made some changes. In this case, the sensor is connected to an embedded system that is constructed using a Raspberry Pi or an Arduino, and then it has been joined to the cloud through the gateway. So gateway is involved in this route also, but sensor is not directly connected to the gateway. It has been joined to the embedded system. Embedded system is connected to the gateway and then to the cloud. In this, the sensors will sense the parameters and it will send this data to the embedded system, where it would be processed and the information is given to the cloud through the gateway. Where we use this? This is used in developing a proof of system, that is to build up a trial system. In this case, we will be using an embedded system that is developed using RPi or Arduino. Then the parameters would be checked of the system that has been designed, and if the system is satisfactorily operating as per the requirements, then and then only the final customized product would be developed using a digital signal processor or a peak microcontroller. That means this approach is used to develop a trial system, so that instead of constructing a conventional system, we will first of all build up a trial system by using this kind of a routing mechanism, and if it is found satisfactory, then only we will go for developing the customized product. So this is a cost-effective mechanism. It can be used in different sectors like image processing, agriculture, and discrete automotive. The next data route is sensor to cloud directly. In this route, the sensor will have a processor which is sophisticated enough to configure the data to be sent to the cloud. The Ethernet connection would connect to the wired internet service. The processor could also have the ability to update or modify the functions of the sensor. No radio link is involved. As we can see in this diagram, there is a microprocessor which is built up inside the sensor, which will configure the data and then it will be given to the cloud on the Ethernet connection. So these are the different data routes available between the sensors and cloud. As per the system that has been developed, as per the requirement, the typical data route between the sensor and cloud can be selected. At this level, students can attempt MCQ Set 2. So at the end of this presentation, the learners would have understood the various data routes which are available from sensors to cloud, and as per the requirement, they can select a typical one. So thank you and have a smart learning.